let me move to the presentation. So thank you to be here. Thank you to Alberto, Avanscoperta, Enrico for inviting me here. So this evening, I would like to present you how it's easy to implement your microservice architecture with the support of Axon platform. So my English is very terrible, and so if you don't understand something, please ask me to repeat. So this is me. My name is Sara Pellegrini, and I work. I am a freelance. I work now from 1 year as a software engineer in Axonic. And Axonic, for those who doesn't know, is a company that provides tools and products for helping people to build event-driven applications. And in Axonic, I work mainly in the development of Axon server. So this is me in my real life, but today I would like to play a game with you and pretending to be someone else. So some of you is passionate like me of Netflix, maybe? No? Maybe you have saw the film, the movie that is named Bandersnatch in Black Mirror series. So for those that never seen this film, I explain very quickly how it works. This is an interactive film because it's the viewer that can choose the story and making decision for the main character, that is Steven Butler, a young programmer of video games. So for this evening, I would like to impersonate Steven Butler. And in my story, he is not a young programmer, but is the leader of the development department of Tuckersoft. That is a company, a software house, a famous and large software house that decided to completely close all the physical office to be completely distributed. So I will ask you to help me making important decisions, and you can help me using your smartphone. So we can immediately try to use the tool that I've chosen, that is this tool. So you can connect to poolev.com/sarapellegrini015, and you can try to answer to this first question, just to try the tool. So have you ever heard about Axon framework? Or this is the first time?
First time.
So you can connect to this page and start voting. Pellegrini. Okay, give you a few seconds for voting.
So next time, like a QR code to scan. Next time, a QR code to scan would be quicker.
Yeah, you are right. Okay, so don't leave this page because you can use this to respond to the other question. So let's start with my boss that came to me and tell me. So we have decided as a company to close all our physical offices. So it's very important for us to create an ecosystem of integrated tools that help our people to be productive and to stay connected, even if they are not co-located anymore. So your mission is to create this suite of tools. It's very important that these tools can manage the complexity of the interaction between the people that we have inside the company. And it's very important that it is flexible, because we want to be able to change the behavior anytime we want to change our internal processes. And it's also important that many teams can work together on the same project, maintaining agility, so maintaining different release cycle, for example. And also, if this project work well, we want to be able to sell this as a software as a service. So this is your mission, and you need to start to implement this product as soon as possible. Okay, so the first question that, the first decision that I have to make, and the first question that I ask you is, what do you think that is better? An architecture leader-oriented, or layers-oriented, or microservices-oriented?
To me, it's close. It depends.
So, to help you, I would like to focus on the core drivers of this project, that are agility, flexibility, and also to the complexity of the domain that we want to map. Okay, so you chose a microservices-oriented architecture. So let's go for microservices architecture. It's a good choice because anytime we have to face with a complex domain, having microservices can help us, because the concept of microservices is a new way to face the complexity itself. Because the idea is to split our application in some logical unit that can be completely autonomous and that are small enough to not have to face complexity. So to be, if we face complexity inside a microservices, maybe we need to split it in more parts. So this is a good choice. Oh, sorry, but. I need to know now if it's better for me to start splitting immediately my application in several microservices, or to start writing a monolith that is well structured and that can be divided in the future in several microservices. Okay, so you decided to go for writing a friendly monolith. This is also a good choice, and because starting immediately writing microservice architecture is very risky for two main reasons. Because first of all, we don't know the boundary of our context. Because we know that writing a software is a learning process, and at the very beginning we don't know a lot about our domain. So maybe we can take time and working on a monolith, exploring the domain, and when the time is right, we can split our application and obtain the several microservices. So the problem is that if we don't work well, maybe it can be difficult later when we have to split the monolith in several microservices to do this in an efficient way, so without a process that is too expensive. And we want to have a monolith that can be easily splitted, so that we can in time separate all the components and maybe scale some of them to obtain at the end a completely microservices architecture in a transparent way. So what we can use to be able to do that in a proper way. So we can use, for example, the common responsibility segregation pattern. So this is a very simple pattern because it says a simple thing, that our application should be divided in two different parts. One is responsible to give us the information, and the other one is responsible to change this information. In other words, if we want, for example, to get some data, we can send a query to our application. If instead we want to modify it, manipulate this data, we can send a command to the application. So if your application implements the common query responsibility segregation pattern, you have two different domain models. One is the command model, and is the one that handles the commands, and is the one that is responsible for making decisions based on the status of the model itself and the content of the commands. So this command model contains aggregates, and in a few moments we will see what is an aggregate. On the other side, we have another model, a read model, that is the one responsible to give the information as quick as possible and in the correct format. So this is the purpose of this model, and is made of projection, and then we will see also what projection are. So the two domain models can communicate, so are separated and independent, and can be synchronized with events. So just to summarize, we see that we have three ways to communicate, to synchronize the components. So the commands, the queries, and the events. The client that interacts with our application sends a command to our application that is handled by the command model, and so the aggregates. The command model makes decisions based on the command itself, and validate the commands and check if the command can be done, and generate events. The events represent a fact, something that is happened, and is a true, and is normally expressed in the past, because it represents something that is happened. And the event is propagated to all the other components. The projection uses this event to update their state. At the end, our client can interact with the application again to retrieve the data, so the information, sending a query. So this is the way a CQRS application works. We can focus on, we talk about aggregates. So aggregates is a very important concept that comes from domain-driven design. And it's very difficult for me to summarize in a few sentences, but I will try. So the aggregate is a graph of one of few entities and value object, and is represent our unit of consistency and persistence. So it's important to say that the aggregate is responsible for its own consistency. So it's not without any behavior, but it implements the behavior to validate their own consistency. And the other very important stuff to say is that the aggregate is absolutely not referring directly any other aggregate. So any aggregate can refer the other aggregates in an indirect way. So just to make an example, if we think this model of an e-commerce application, we can have the order entity, the customer entity, and the product entity. And in a traditional domain model, maybe these entities are correlated, are directly related with foreign keys. So, for example, the order is related to the product and to the customer. If we think in aggregate, this is not more true. So we can have three different aggregates. One is the customer, one is the product, and one is the order. And each aggregate can indirectly refer the other aggregates with the aggregate identifier. So in this case, for example, the order line as the product identifier, that is the identifier of the product. But they are independent. They are not directly they are not directly connected with the foreign keys. And as you can see, it's easy that, for example, some information, like, for example, the price of the product is replicated in the order line. So there are some information that can be replicated in several aggregates. Okay. So let me talk about, very quickly, about the way that we can use to store, to persist the aggregate. So we can use two ways mainly. One is the traditional way, so to persist the state of the aggregate itself. And we can do this with ORM framework or everything. So it's very common. And the other way is the event sourcing. So the event sourcing is so we persist an aggregate persisting the full history of events that are happened to that aggregate. So to recreate the last state of this aggregate, we need to reapply all the events that are happened to this aggregate from the very beginning. So most people say, but why you have to complicate your life making this strange way of storing aggregates? So the reason is explainable with an example. If we think a bank account, that is the typical example that we do in this case. So we can have an information that is the money that we have on a bank account. This information is not important by itself, but is important within together with all the transactions that are happening on my bank account to arrive to the total at the end. So it's very important to keep track of all the transactions that are happening to arrive to this balance at the end. So this is very important because we talk about money, so it's something that we want to track in a very detailed way. Maybe in other contexts, it's not so clear the importance to track all the transactions, all the events that happen to an aggregate, but the event sourcing represents exactly this. So to use the same way that we use to persist the state of a bank account for all other entities, for all other contexts. So there are many benefits in doing this practice. So none of them is technical, so we don't have technical benefits. It's a complication in technical terms, but we have business value because keeping track of all the events that happens to an aggregate is important because we maintain a lot of information. So let's move to see something more about projection. So the projections are part of read model and represents specific views that are created to simplify queries in order to provide the information as quick as possible and in the correct format. So we can assimilate the projection to materialized view, or persisting view that are exactly the form that we need for our user interface or for our specific use case. So instead of a unique domain normalized that maybe can cause some problem because maybe to obtain the data in the correct format we need to have a very complex query with a lot of subquery with performances problem and readability problem. Now we have a different independent view that represents exactly the content that we need to read for this specific use case. So one of the advantages of the projection is that you can use different technology. For example, if you need, for example, something that you want to search, for example, if you want to do some text search, you can choose the correct technology. If you prefer a relational database, you can choose another technology. So, it's easy to understand that this has one consequences. So we can simply say that the common query responsibility segregation used together with domain-driven design principle like aggregates, for example, is very useful to keep our monolith well structured. And why is that? Because immediately we can see that the common model and the read model are two independent parts that can be deployed in a separate way. And also we have projections that are no more a unique big domain, but are composed on small domains, small materialized view that represents one specific use case that can be deployed autonomously if we need. Maybe we don't need, but potentially you can. And in the same way, also aggregate can be autonomous microservices because they have no strong relationship between them. So this is a good technique to keep our monolith well structured and to keep our domain loose coupled so that we can split them in the future. So we have so these first 3 points that are CQRS, event sourcing, and domain-driven design that can help us to keep the monolith and the boundaries between microservices. Now we need one other step, one other feature to be able to split the monolith in a very efficient way. So this is the location transparency. So the location transparency allows us to evolve from a monolith to a microservice architecture in a simple way. So the location transparency is the concept that say that all the components doesn't know where the other components they interact with are located. So if, for example, your components, that can be in this case one aggregate or one projection, can communicate with other components, it does that with commands, events, and query. So it doesn't know exactly where the other components are because someone else is responsible to dispatch, to route your commands, event, and query to the correct component. So this is the way we use to implement the location transparency. So try to put in practice this concept with the Axon framework. Axon framework is a framework, an open source framework for writing event-driven Java application. It is useful to implement domain-driven design concepts like aggregates, CQRS application, and it supports the event sourcing persistencies of the aggregate, and it enables with the implementation of the location transparency to evolve from a monolith to a microservice architecture. So besides Axon framework, we have Axon server, that is the other part of Axon platform, is an open source product that acts mainly two-way. So is an event source, so is responsible for the persistence of the events, and is a routing platform. So implement the location transparency because all the components that we have can connect to Axon server and doesn't know exactly where the other components they interact with are located. So is Axon server that is responsible to dispatch events, command, and query to the other components, depending to the kind of message that we are talking about. Okay, so we have 2 Axon server versions. We will use the standard edition, that is the open source version. There is also an enterprise version with some additional feature. So, for example, if we want to start to implement our application, which technique do you want to use in order to explore the domain of events? Okay, very smart choice. You choose event storming. So after a long session of event storming, we extrapolate a little portion of our timeline that contains a chat module part, chat module, events and commands. So let's start to analyze, for example, the room create the events that is generated from the create room commands. The participant joined the room events that is generated from join room commands, and the message posted events that is generated from post message command. So all these commands are handled by the chat room aggregate that is responsible for generating these events. So besides that, we have some read models, some projections that are useful for our application. And in particular, we want to read all the rooms. We want to be able to show all the rooms to the client. We want to read all the room messages, and we want to see the room participants. So let's start to focus on this first part. So the aggregate, the command model, and the chat room aggregate, and the commands and the events that you manage. So in a typical CQRS application, the structure can be more or less like that. So we have a user interface, command handler that manages commands with the aggregates, and then the commands are persisted in the event store. And then the events are persisted in the event store, the events generated by the aggregates. But let's try to do that. So in order to use Axon server, you can start simply a Docker container. So you can run this command. I have already do that, and I have my container running. So try to use this. So this is my container. Maybe it's too small for you, but it's running here. So if you see, this is the user interface of Axon Server Standard Edition. Simply say that. We don't have any events command query yet. So I have created a very simple Spring Boot application. You can use Axon with or without Spring Boot, but with Spring is more comfortable, simply is more easy and fast. And let me show you simply the POM. I have only two dependencies. So the Spring Boot starter dependency, that is the one that I need to use Axon framework, and the Spring Boot starter web that is simply needed because I want to expose some REST API to show you the functionality. So I have created here in the application 4 packages. The API package that will contain the API of our component. So the API in our case are the commands, the events, and the queries. And we have a command model that contains our write model, so our aggregate in this case. And we have a package for query models, and then we have a package for a REST API for exposing this as a REST endpoint. So let's try to start writing some commands and some events, and to create our aggregate and to see how this works. So first of all, I create a command that is create room command. Okay, I need to specify an aggregate identifier that in my case is root ID. So creating this class, you can see that this is a message, so is an immutable object, and is in imperative language, so create room because it's a command. And you can see that I use this annotation that is needed to Axon framework to identify the correct aggregate that I need to deliver this command. So let's create also the event. The event is, in this case, a room created event. Okay. And we can see that the room created event is in the past tense because it's a fact, it's something that is happened. So in the command we maybe need to add some information, like for example the name of the room. So we want to add this information and also an accessor for this. Okay. And also the event contains the same information, because when we create a room, we want that this room has a name. Okay. So we have this command and this query. So we need now the aggregate. The aggregate The aggregate in this case is the chat room. The aggregate identifier is the unique identifier for this object. So we can see that for creating aggregate is very simple. In Axon framework, you can, using Spring, you can simply annotate your aggregate with an aggregate annotation. The aggregate identifier annotation is the one needed for the framework to know what is the property, the field in the aggregate that is the identifier, and so to deliver correctly the command to that aggregate instance. So let me show you something here. So now you can see that in this overview, Axon server, there is one instance of Axon server that is not connected to any application. So if I start this application, here. You can see that now never is changed, because the application is not providing any command handler and any query handler. So let's add this command handler and this query handler. How we can do that? So in our chat room aggregate, we can add the command handler that can manage the command that we receive. So we now have one single command, and is a specific command, the one that creates the aggregate. So in order to handle this kind of command, we need to annotate the constructor of our aggregate with a command annotation. So let me show you. Okay, so this is a constructor. The first parameter, the first field of the parameter of this constructor is the events of creation. So create the command of creation. So create room command. Very good. And the constructor is annotated with the command handler. In this way, the framework knows that this method is used to handle this kind of command. So the command handler is responsible to validate the command and to check if we can do that. So in this particular case, we don't want to check anything, and we can simply generate the events that the room is created. So to do that, we can use the apply static method. Let me show you. So new room created command event. Okay, the content of the room created event takes from the command state. So it takes the room ID, it takes the name. Okay, as you can see, I don't change the status of my aggregate inside the command handler, and this is because I want to use the event sourcing. So the event sourcing require me that any changes to the state of the aggregate are performed in one other kind of method, that is the event sourcing handler method. So you can see that our event sourcing handler method receives as an argument, as a first argument, the event that they handle, in this case the room created event, and are responsible to perform any status change in the aggregates that came from this event. In this case, we want simply to set the room ID. Okay. So now we have a command handler and an event sourcing handler. We can redeploy our application. Okay. You can see now an instance of our application that is connected to Axon server. So this is the overview. If you click, you can see the detail. In this case, we have only one command that is handled by this application, that is the create from command. Let's implement the other commands. So for simplicity, I have prepared here some other commands and events. So let me try to that are, for example, the join room commands, the leave room command, and the post message command. And some events that are the message posted event, participant joined room event, and participant left room events. So let me revert this. All of these commands and events are exactly the same structure of the one that we created. So they are immutable objects that have target aggregate identifier notation on the identifier in the commands. So let's try to implement these commands handler in the chat room aggregate. So we know that now the aggregate is created, so the other command handler are no more the constructor of the aggregate, but are simply method. So for example, to handle the join room command, we can simply create a method annotated with the command handler that take as a first argument a join room command. So in this case, we don't want to accept the commands without verifying anything. We want to verify that the participants is not already part of this room. So to do that, I need another information here. So I add a set of string that are the participants of the room. Okay. So in the command handler, I simply can verify if the participants doesn't contain the new participant, and if it doesn't contain, we can apply the new participants joined room events, with obviously the information derived from command that are room ID and participants. So if the participant is already part of this room, we simply don't do anything. So we don't want to draw an exception. We simply silently accept the commands without generating the events, because the participant is already part of the room. So we need also to add an event sourcing handler that manages the participants joined room events. And in this case, it simply can add into the participants list the new participant. And the same way, we can exactly do the same with when a participant left. So we can have a command handler for leave room command, and that check if the participants is contained in the room, and if it's contained, we generate a participants left room event. And the same way, we have an event sourcing handler for the participants left room event that change the state of our aggregate, removing the participants. Very good. At the end, we need to handle the message posted event. So to do that, a message posted command. Okay. So in this method, we want to verify that the sender is, because our chat room is consistent, we need to check if the sender is a part of the participants. But if it's not part of the participants, in this case, we don't want to silently accept the command, but we want to throw an exception. So try to search that the participant contains the sender. Okay, so if it's not, we throw an exception with this message. Okay. So the exception is thrown anytime the participant doesn't contain the sender. If it contains the sender, we can generate the event. So in this case, we can generate a new message posted event that contains the command ID, the command. Let me see if the participants is okay. Common participants and common message. Okay. Everything clear? Okay. If you have a question, you can interrupt me. So, as you can notice, I have no information in this aggregate, like for example the name of the room. And why is that? Because using event sourcing, I can keep in the aggregate only the information that I need to verify the consistency of the aggregate itself. So we have some rules that are, for example, the fact that no one that has not joined the room can send messages. So we need the participants to do that. But for example, we never use the name of the room for any check, any validation. So if in the future we will need to have this information, we can add it. Because the aggregate is recreated, creating a new, fresh class and applying again all the events that happen on that aggregate. So if we need this information in the future, we can always change the implementation and add this information. But it is important to know that we need here only the fields that are useful for validation of invariants inside the aggregate. Okay, so let me try to redeploy our application and to see what has changed. So you see that now I handle these commands, so all the 4 commands that I implemented in the chat room. So now we want to test this application. To do that, I have prepared a couple of controllers, a REST controller. So let's start with this REST controller. So this is a simply Spring REST controller that I created in order to send all the commands that we have. I prepared these 4 methods that this one is for to create a room, this one to join the room, this is to post message, and this is to leave the room. So how can I send commands to my components? So I can do that with this interface. So this interface is provided as a Spring component if you use the Spring integration. So you can simply inject the command gateway in your Spring bin. You have this command gateway, and you can use this command gateway to send command in a comfortable way. So let's try to do that. For example, we receive a post request to create a room. So we need to take the identifier. The identifier can come from the request body or not. For example, if it comes from a request body, we can take this one. But if the request body doesn't contain the identifier, we can simply generate a new identifier. Then we can use the command gateway to simply send a command. So which kind of command we want to send? Create a room command that contains the identifier that we created and the name that we receive from the post request. So the same way we can implement also the other commands. For example, we can use the command gateway to send a new join room command that contains the room ID and also the participant. Exactly the same way we can implement the others. So let me do that to be faster. Okay, we use the command gateway simply to send these commands to our components. So let's try to redeploy the application and to test the behavior. So I have prepared here some requests. So this is a post request that contains an identifier and a name for the room. So this can be converted from my endpoint as we seen here to a command that is sent to my component. So let's try to run the request and to see what happens. Okay, as you can see, this is a creation command that returns the identifier of the aggregate that has created. In our Axon server, you can see that now if you search for the events, there is one first event. Is the room created event. This is the payload of the room created events. And this is the payload type. So the aggregate type that we are working on is the chat room, and this is the identifier of the aggregate. So if I, for example, want to join the room, I can send this post request. No, this is for create another room. This is for join a room. Okay. So as you can see, the envelope here is empty. If I run, so let's see now that we have 3 commands. So 2 commands for create. Can you see can you read? More or less. So these 2 commands are the creation commands, and this one is the participant join a room event. So, as you can see, this is a global identifier, a global sequence that is for all the events that we have in the event store, while this is a relative sequence that represents the sequence inside the same aggregate. So if we run again the join room command with the same participants, we don't have any error, so this command is accepted as the one before, but no other event is generated and persisted, because we have checked in our aggregate that the participant is already part of our aggregate, our chat room. So I can try now to post, to send a new message to the chat using Stefan as a sender. And as you can see, now I have this new message post events in our event store. If I try to send a new message with a sender that is not part of our chat room, in this case, you can see that I receive my error. You must be in this room to send a message. So we have tried to send commands, and we have seen that our aggregate validates the consistency, its own internal consistency, and we now want to try to create our projection using this component. So let's do that. So we focus now on this part. So we have the events that are generated from our aggregate, and we want to be able to create the projections, so the read model that our client needs. In order to do that, I want to explain you about a couple of things. So Axon Framework provides the event processor to implement our projection. So the event processor can be of two different types. So we can have a subscribing event processor or tracking event processor. So the main difference is that in the subscribing event processor, the handler of the events run in the same thread that is responsible for publishing the events. So the main advantage is this one, that the handler can participate in the transaction of the command that is sent. So in other words, if for example this handler generates an exception, this can be used to roll back the full transaction that created the event. That is useful, for example, in case like set validation. So we want, for example, that a username is unique. When we have this handler that throws an exception because we found another username, we can roll back completely the transaction and so roll back the events. The tracking event processor on the other side is running in its own thread. So it's subscribed to an event source, and it's running on its own thread or multiple threads. The benefits in using the tracking event processor are several. For example, the fact that if you have an error for a temporary unavailability of the database, your handler go in retry mode and try again to process the events that cause this error with incremental backoff time. So for any error, we have a greater backoff time. And another advantage is that with the tracking event processor, we can, for example, reply all events from the very beginning. So create new projections that start replaying events from the beginning of the history. So I would like to ask you, which kind of processor do you prefer to see today, to use today? So if the subscribing event processor or tracking event processor for implementing our story. Suspense. Oh. Okay. So let's do that with the subscribing event processor. So in this case, we want to create projection for implementing these queries. So for read all the rooms, all the room messages, and all the room participants. So let's try to do that. I have prepared here in the query model some simple entities. So the chat message that contains the room ID, the participants and the message, the room participants that contains the room ID and the participants, and the rooms that contains the room ID and name. So in order to, I need to have a JPL support for from Spring, so let me enable this dependency. I add the Spring Boot starter for JPL and the H2 in-memory database. And so I can revert this tree file to get the, let me do that here. So I simply added this JPR notation in order to have this persisted in our relational database. So I have created the entities and the repository, the JPR repository for this purpose. So we need simply to create our projection. So the projection that we want is simply a handler of the events that are interesting for creating this table, so this projection. We can start from a room. We can create a projection that is a room projection for this goal. Okay. So let me write an identifier for this processing group. So as you can see, the room projection is I use a template to generate this, and I simply need to annotate a class with components, and you see that I have injected a pre-update emitter, so we don't need now, we will see what is it later. So in order to create our projection, we simply need to listen to the room creation events that are the only important to create the list of room. So we add one event handler that listens to the room created event. Okay. In this case, we need to use the repository, the JPR repository, simply to generate a new entity in the so the new room as content the event identifier and the event name. Okay. So if I deploy this application, I need to tell you that in order to perform this, so to use the subscribing event processor, I need to make a change in the configuration of the processor, because in Axon framework the default mode is tracking event processor. So if you don't configure anything, all the event processor are started in the tracking mode. If you want to enable the subscribing mode, you can use property to enable a specific subscribing mode for one single processor, or if in our case we can do that for all of them. How we can do that? So we simply needed to use this Axon processing configurer and to call this using subscribing event processor method. This is very simple to move from the tracking to the subscribing as default mode. So we know that now subscribing are not receiving all the events that are already created in the event source, so we need to generate other events in order that this projection works. So let me try to redeploy this application. Now you can see that. We not only have this command and handler, but we also have this processor, that is the room processor in a subscribing mode. And you can see that in database that I have created, let me see the database of the chat. So if I try to see what is in the room table, I can't find anything. And why is that? Because it's a subscribing event processor. So it doesn't process the events from the beginning, but process only the events that are published after the creation of the subscribing event processor. So I needed to send another commands of creation to see the result. So I can simply create another, well, this one is already, another room, and now if I interrogate my table, I see that this is created. So the difference between subscribing event processor and tracking event processor is that tracking event processor replay from the beginning all events that are already present in the event store. Subscribing event processor are processed in the same thread, so they need to be implemented before they work. So they work from the moment they are delivered. So let's do the same for the others. So projection, let me implement the participant projection. Okay, so we have this projection also for participants and for this is not okay. Okay. So, and for chat messages, I have reverted for these chat messages. Okay. So now we have the same projection also for these two other kind of, let me remove these lines that I want to show you later. So now we have, there's something else, okay. So now we have these implementation that are useful only if I need to create so these implementation are used only for the events that are generated after the implementation, because we choose subscribing event processor. So let's try to do the queries now. We want to interrogate the table that we have just created. How we can do that? We can create the query message that are the last API that we are missing. So let's try to create the query message, and in order to do that, I want to ask you something more. So we are focusing now in this part of the application, in the last part. So we want to interrogate our projection with the queries from the client, from the user interface. So in order to do that, Axon Framework provides us three kinds of query. Now we are focusing on two of them, that are the direct query and the subscription query. So the direct query are a simple query, simply handled by one single handler. If there's no handler to respond to this query is through an exception. If there are multiple handlers that can respond to this query, one is chosen from the query bus implementation. So the subscribing query are the same of the direct query, but with one function more, one feature more, that is the fact that we can, for example, we can use this for chat messages. The subscription query is useful all the time that we want to retrieve an initial result, and then we want to subscribe to the update for this query. So for example, we can do that for a chat message. We want to receive the last, the current messages, and then we want to listen for the update of the new message that arrive in the same room. So what kind of query do we want to see now? The direct query or the subscription query? Okay, so we we have seen the direct query. So let's try to do that. So we can simply generate a query that are simple messages. So we need, for example, we want, for example, to see the messages. So let me create one class that is the room messages query. Okay, so this is a message, so it's an immutable object like the other. The only information that I need is the room ID, because I want to filter the messages for room ID, so I need simply the room ID as parameter, and that's all. So in order to, exactly like commands, in order to handle this query, I need a query handler. And the most correct place to place this, to put this query handler is the same projection that generated the data. So let me go in the chat message projection. Here we have this event handler that has received this, that handle these message posted events, and for each event generate on the repository one new chat message. So we want to add a query handler method, and this query handler will return a list of chat message. So this query handler manages this chat room messages query, and it returns a list of chat messages from finding, filtering in the table by room ID. So the query message contains the parameter that I need to get the result. In this case, the room identifier. So I have prepared a query controller. This query controller is exactly the same way of the command controller. Can use a query gateway in order to send easily the query to my components, and let me show you here. We can use the query gateway in order to send, to query my components. So the signature of a query is not only the message itself, but also the return type. So we want to receive, we want to send a query that is a room message query that contains the room ID, but also we want to specify what kind of result we are expecting. In this case, we want to a multiple instance of chat messages. Okay, so let's try to do that. So in order to try to do that, I need to send some message. I need to publish some message, because with the subscribing event processor, the messages that are already present in my database, the events that are already present in my database are not used to generate the projection. So I have sent a couple of commands to send a message that are transformed in the events, as you can see here. So we have some new events for a message posted. And in the table, you can see that now we have the messages. We have not.
You need to restart.
Yeah, thank you. So I need to send them again because I haven't deployed the projection. So I have not implemented this query yet. Okay. So let's try to create another couple of messages. Let's see that if now they are okay. There are two records in the table, the records of events number 5 and number 6 that are the one that are generated and published after the projection is available. So now we want to try to query this, and we can do that with a get request of messages, so this one. And we can see that sending this one, we simply have the result that we are expecting. So the messages filtered by room identifier. So in this case, the only one that we have created. So we have completely we have completely our implementation. So we have implemented the commands, we have implemented the events, the aggregate that handled this command and generated the events, the projection with the event handler, and also the query that can allow us to interrogate this projection. So we have finished our mission. So now we are able to scale our application. So we can simply do that. I can simply show how to do that. So we can split our components, so our aggregate and projection, in several applications. So you can deploy them separated. And I have prepared another application here just to show you how it works. So any application can be connected to, can be deployed and register itself to Axon server, and this Axon server is responsible to manage the communication between the components. So you don't care if your components are deployed in a single jar or in a several jar, because is Axon server that take care of dispatching the commands, the query, and the events between the several applications, so that everybody can work without knowing exactly where the other components lives. So in this way, I have created another application. So in the overview, you can see that we have two applications connected to Axon server, and I can, for example, replicate, so create another instance of this application to scale this second application. And I simply deploy the same application on a different port. And it is enough for Axon server to realize that there are three instances, and to use these two instances to split the load on the command and query and events that are part of this implementation. So thank you very much for your help. You have helped Stefan to be promoted, so I'm not fired. And if you want to give me some feedback, you can use the same tool to respond to a very, very small feedback form at the end. So I am available for any question if you want.
I have 9 questions.
Very good.
Let's make a poll. Well, I'll try to be quick. What about versioning events and structures? Should you evolve what you're storing over time?
Okay, so so there are several ways to versioning events. So Axon provides a caster. So first of all, I would like to say that I prefer very small events because I've tried both. I tried using very large events with a lot of information inside, and try to use very small events with very specific information and aim. So I seen that in this second case, I don't need a lot really to versioning events, because the versions are so small that it's difficult that I need to change them. It's more easy that I need to add a new one, but not to change the previous one. So, in my opinion, it's useful to have these small events. But if you need to versioning events, you can use Upcaster, that is a sort of deserializer that takes the previous version of the events and deserialize in a new version of the events. So it takes the raw form that is persisted in the event store and map this form with the new version of the last version of events. So this is the...
And how do you handle the change of structure in the code that somehow interacts with those events? Say that you have like version 1 of your code base and then version 2, and then you have some events floating around in version 1, you start deploying the version 2, and then the version 2 starts a meeting event while version 1 is still like live. Imagine like
so,
a rollout kind of thing, or maybe a queue or something.
Okay, you're talking about you have two different versions of code that generates events at the same time.
Yeah.
So it depends, but you can, for example, manage the events keeping two different, for example, events to instruct the application to handle one kind of events only with some projection that are able to catch the new events. So to have two different kind of events to not have this kind of overlapping. Or you can for example, try to make an intermediate step and to not have two versions that has the possibility to mix this event handler with the different version of event generated.
Okay. Maybe I'll pick one and then I'll bother later. Let's talk about like storing events.
Yeah.
The two main strategies that I have seen are either, well, three. One table or whatever for everything. One table per kind of aggregate, or one table per each aggregate.
Okay.
Pros and cons, suggestions,
okay.
Something in between.
The point is that you are talking about table, and so the event store implements, the Axon server implements an event store for a reason, because when we have a billion of events, a table is not very performant, because you have in a single table really a lot of records, and even if you use the correct indexes, it's not enough to maintain the performances in the time. So we have some advantage in implementing an event store. That is the fact that the event store is append only. So we never modify the past. We only add the new information. So this can be used to create a simplified version, so we don't need all the features that a relational database can give us, like for example update records or delete records, because in the database we don't need these features in an event store. The event store is append only. So we have implemented an event store that is not based on relational database, so it is based on file and use specific index to retrieve the aggregates, to retrieve the events filtered by aggregates, or to retrieve all the events from the beginning to the end. So this is possible because there is another simplification in the case of event store. You have to query the events usually in two ways. You can query the events by aggregate because you want to recreate with event sourcing the structure of the aggregate, or you want to query all the events in temporal sequence, so following the timeline. So the first goal is you can obtain this goal with an indexing on the aggregate identifier and the aggregate type. And the second goal is very easy because if you use file, you can simply read in sequence the files that contains all the events. So in this case, I can say that I usually use in relational database one table for all of events, but I had problem of performances. So I had a table with a billion of events. So at the end, there was some issue and a lot of work trying to improve performances of the database and not to focus on the business. So that's the reason, because it makes sense to write an event store, in my opinion.
Yeah, my problem is I can't choose another data storage. So
Okay.
it's MySQL or
Yeah.
Mongo or Dev.
Okay.
Probably Dev would be.
So with MySQL, I try to use Percona implementation that helped me a lot, and also I try to use some improvement in the. I remember something. It's a lot of time ago, but some improvement in the compression way of the events that is a lot more faster than the full one. So these are the improvements that I did to make it faster. But I understand that, I know that there is this problem. And it's mainly because our relational database is not the best way to persist events. To start, I also started with that.
Thanks.
Just a question about the deployments. Not about deployments of your code, but deployments of the Axon server itself.
Mm-hmm.
Which kind of configuration do you suggest to deploy in a multiple server configuration? We have to prepare a master node and the slave nodes.
So if you talk about the Axon server standard edition, there's no cluster feature available. If you talk about the enterprise edition, yes, you can deploy Axon server in a cluster mode, so you have multiple nodes.
Okay.
So the way it works is, so the way we implemented consensus is with the Raft protocol, and several nodes found a leader, elect a leader that is the one that is responsible to replicate the events to the others. So you need to have an odd number of Axon server because obviously you are tolerant to many failures. So for example, if you have a cluster of 3 nodes, you can tolerate the failure of 1 because you need the majority of nodes to the cluster to work. If you have a cluster of 4, you can tolerate the failure of 1 because the majority is 3. So it's not convenient to have a cluster of 4. So always odd number of nodes in a cluster, and you can choose if you want 3 or 5 to tolerate 2 failures. So that is the configuration that we can suggest. Inside the configuration itself, you can choose, for example, if you have a node of 5 instances, if you use all the 5 instances for all contexts or bounded contexts, or you can maybe choose to use only 3 instances for one bounded context and 5 for the other one. So you can configure independently.
Okay.
So another question is about testing
Mm-hmm.
and unit testing, integration test. Does the framework provide us some tools or?
Yeah.
Yeah, because.
So we have, so as you can see, all the interaction with aggregate and projection happens with the three messages that we have. So event, comment, and query. So we provide support for testing aggregates. That is following the pattern given when done. So given a list of events, when a command happens, when a command is received, we expect that these events are generated. So this is useful to test in a very easy way the command model, so the write model. We want to write something exactly similar also for the query, for the projection. That is something like given this list of events, when I receive this query, I want to return this result. That is exactly the same interaction that we have in the command side. So given when then, but obviously not with command, but with events and query in this case. But this is not yet implemented. This is in the board.
One other?
Yeah, go ahead.
So we talk about multiple instances deployed of the same service. What about competing consumers? Because at that point, if for one message sent on the event bus, we can have like two consumers that read the command and process the command. Is handled by the framework itself, or
so
what's the strategy?
when Axon server acts as a routing message, and when we have, for example, multiple instances of the same application, we have different strategy depending on which kind of message we are routing. For example, in the case of command, the command bus decides one single command handler. So if we have two instances, he balances between the two. If we suppose that the code is the same, so we can route the command to one or the other instance. In case of projection, the story is different because events are important for all event handlers. So events are published for all the event handlers that we have in the application. So in the case of projection, for example, if we are using a tracking processor, so not the one that we have seen this evening, but the other one, so tracking processor work in this way. They can follow the stream of all events in the event store, and they keep track of the position that they have processed with an index that is named token. So this token keeps the track of the index of the last sequence of the events that is processed. So if I have multiple instances of a tracking event processor, for example, I can split the events on the two instances to load the balance. In this case, I have two tokens that can maintain the index of the two different instances. So in this way, maybe we can say that the half of the events are managed by instance 1 and the other half by instance 2. And the two tracking tokens keep the index to maintain the track, yes, and to split the load between the two instances. So we have several different strategies depending on what we are dispatching.
Okay. And is configurable on the fly, or we need to
Yes,
restart
so this is configurable with, you can use a spring property, for example, to say how many instances do you want for this tracking event processor, depending on how many how many threads do you want for the tracking event processor, depending on how many instances of the application you have. Now there is a new feature that allows you to split on the fly without redeploy the application, the tracking token, to make this balancing between the nodes. So if you have two instances and you have, for example, one single token, you can split automatically this token in two so that the other one takes the half of the events and can both work on the same projection.
And how to deal with errors, like errors in the subscriber responsible of replicating of handling the event on the query component. So if something fails in updating the, let's say, relational database.
Okay, it depends. Because if you want, for example, that this error invalidate completely the transaction, the unit of work that is generated while the command arrives, it's better for you to use a subscribing event processor. In this case, when the subscribing event processor is invoked, this happens inside the same threads that come with the event publishing. So if, for example, you have an error writing your record on the database or whatever, you can invalidate completely the transaction and roll back also the generation of the events, if you need, obviously. In the tracking event processor, it's completely different. So if your aggregate has emitted an event and this event is committed, so the tracking event processor simply has to accept that this is happened, this is a fact, this is already committed, this is in the event store. So the tracking event processors can simply retry to process these events. So it's very important that you have a way to monitor your tracking event processor, because if, for example, there is a bug or something in the tracking event processor, you cannot have any evidence in your client, because the tracking event processor works in another thread and simply try again to process the events. Maybe for a bug it doesn't work, so you have to be aware that tracking event processor that are not up to date with the last events. So there is a little delay, obviously, that is the eventual consistency that comes from the fact that they are running in two different threads, but the most important thing is that they are always near to the head of the stream. So. Other question?